This video is going to be about how to do dimensional analysis. So dimensional analysis is used in science classes whenever we are trying to figure out how to solve a problem given the information that we have. And so it's the most commonly used way of solving word problems. So a couple points to remember. It's all about getting units to cross out. So units are your friend. You need to always use units in your answer, but also in your conversions. Units are just like variables and numbers. They can cross out if they are in a numerator-denominator combination. So like this, or like this. Even here, the combinations can be far apart. They can be between things, and I could have a denominator here and a numerator here, and they'll still cross out. And it's all about converting from one unit to another. So the overall look to it is you're going to have your given units to the left. You're going to have a bunch of conversions, and some people like to use parentheses. Some people like to use this grid format because it's just easier to deal with. And then you're trying to get to your units needed. So in general, you want to have the units that you need in the final numerator and your given units crossed out in your first denominator. So it's easiest if you just think about example problems. So for example, if I want to know how many seconds are in 2.5 years, the given unit usually has the number with it. So 2.5 years is our given number, and I would place this over here. Seconds are the units that have no number with it. So I don't know how many seconds, that's what I'm trying to look for. And to go ahead and write the units that you need and leave a space for the answer. And then this large space in between is where you're going to have your conversions. If you can figure out how many conversions you're going to need ahead of time, it will oftentimes make life easier. So I need to be able to convert from years to days. I need a conversion from days to hours. I need a third conversion from hours to minutes. And a final conversion will get me from minutes to seconds. So I'm going to need a total of 4 conversions in this problem. So this is what it looks like. I have my given units here, put my units in first, and then I will put my 4 spaces for the conversions, and I'll put my units in first. So the purple goes in first. So years needs to cross out, so it's got to be in a numerator-denominator combination. And years, remember we had our conversion was years with days. So that's in my first parentheses. Then my second parentheses will be hours to days. So my days will cancel out. My hours and minutes, my hours will cancel out, and minutes to second. And so if you look at the way I've done my units, my seconds is my last unit, or in the numerator of my last conversion. And in the first conversion, my units that I need to cross out for my given units are in the denominator of my first conversion. And in every case, I have a numerator-denominator combination that crosses out hours, hours, minutes, minutes, seconds. Then I put in the numbers for the conversion. I know that there are 365 days in a year, 24 hours in a day, 60 minutes in 1 hour, 60 seconds in 1 minute. Then I do the math. Everything's in the numerator, so all I have to do is multiply up those numbers. 2.5 times 365 times 24 times 60 times 60 equals 78,840,000 seconds. Example B. Here's one where it's a little bit more cloudy as to what is given and things like that. So an example would be, how far will a car travel if it has a velocity of 35 meters per second and travels for 2 hours? So figuring out what's given, what are the conversion, and what is needed is going to be the tricky part. So part of it depends on these words that we often say that have this meaning for a unit. So how far? Far is distance, and distance means that I'm looking for meters. So even though I didn't ask the question, how many meters will the car travel? The words how far are standing in for the units of meters. There is no number given, so those are the units that I need. Now the question is, I have two numbers here. I have 35 meters per second and I have 2 hours. 2 hours is our given because 35 meters per second is a conversion, and a conversion is something that is in a fraction form. So it may not look like a fraction, but because the units are in a fraction, really what this is saying is that this is 35 meters for every 1 second. When I put it that way, it makes it a little bit clearer that I have a fraction and that fraction is a conversion. So again, I have no numbers given with this implied unit of meters, so those are the units needed. 2 hours is the given because 35 meters per second is the conversion. So then I have to think ahead and say, how many conversions do I need? Well, I have the 35 meters per second, that's the first conversion. The second conversion, I need to get to seconds, right? So I need to cancel those out, so I need a conversion from minutes to seconds and a conversion from hours to minutes. So I need a total of 3 conversions. So I set my thing up, and I know that I'm going from 2 hours to meters. So meters, I'm actually going to work backwards. I know that meters has to be in the numerator of my last parentheses. So I have a conversion. The only conversion I have between meters and anything else in my problem is meters per second. So the second goes in the denominator. And because the seconds are now in the denominator, it has to be in the numerator of this parenthesis so I can cross them out. The only other conversion I have with seconds is minutes. So be careful not to use meters per second again. You've already used the conversion. So once you use a conversion once, don't use it again. So seconds goes with minutes. And because I have minutes now in the denominator, minutes have to be in the numerator in this parentheses, and minutes goes with hours. And boom, now my hours are in the denominator and they will cancel out my given units. So sometimes you work forward with your conversions, sometimes we work backwards, and sometimes we will work from either end and meet in the middle. So it's all about figuring things out to get your conversions lined up so that you end up with the units that you want to and cross out every other unit you don't want. Don't want the hours, don't want the minutes, don't want the seconds, I do want the meters. So now then I add in the numbers. 2 hours is given, 35 meters per second is from the problem, 60 seconds in 1 minute, 60 minutes in 1 hour. Now, as you're first starting this out, it's a good idea to, even though it's implied that it's 1 second, to just go ahead and write in the number 1. This is so that as you're checking the problem, you are more confident that what you've put in as a conversion is the right conversion, and you're less likely to second guess yourself. Because remember that checking a problem is not simply setting it up and doing it and plugging things into your calculator. It's really double checking the setup of your problem to make sure that it will lead to the correct thing and all of the other units cancel out. You get just 1 point for your correct number, your numerical answer. This question would be worth, let's count up, 1 point for the unit, 1 point for the number, so that's 2 points, and 2 points for each parentheses being set up correctly with the units and in a way that crosses them out. So this problem is worth 8 points, only one of which is the actual number here. So the setup is all where the meat of the points are, and so you should really get into the habit of setting it up in a way that makes sense. Hope this makes sense.